Hi everybody. In this case, we're going to look at solving quadratic equations. So first to find out how to do it, and then to make sure that we understand the process for it and use it to solve to find an x-intercept. So how do I find x-intercepts for a quadratic equation? Well, if we've just given an equation itself, we have to decide which process we're going to do. So if it factorizes easily, factorize it and use null factor law. If it doesn't factorize easily, is it in turning point form? If it is, rearrange the equation. If it's not, we're going to use the quadratic formula. So here are some cases. First one, we have x squared plus 9x plus 14. That's easily factorizable. So we're going to substitute y equals 0 and then solve the equation by finding when does that, for what values of x will make the equations 0. And null factor law in this case tells us it's -7 and -2. If this is 0, the whole equation 0. If this is 0, the whole equation 0. To make this 0, x must be -7. To make this 0, x must be -2. There's the two solutions. Here's a turning point form equation. So we can't easily put this in factored form where we just have two brackets and 0 on one side. So we'll rearrange it to try and find the solutions for x another way. So like before, substitute 0 in for y. Take 5 from both sides, take the square root of both sides, take 2 from both sides. But when we get to this step, we have a problem. We end up with the square root of -5, which is undefined. So that indicates to us there is no solution for this. The quadratic graph will be above the axis itself. But here's one where that's not the case. So we have an equation in turning point form. Let y equal 0, add 5 to both sides, take the square root of both sides. That's to this step here, not forgetting the plus or minus. Subtract 2 from both sides. I've written it out the front here just to make it easy for us. And now we know that the x-intercepts are going to be at -2 plus root 5. It's one of the solutions. And -2 take root 5. With the line of symmetry at -2. It should be x equals -2. I'll see if I can just put it in with my... Oh, there you go. X equals -2. Now, this isn't easily factorizable. There are no factors of 7 that add to 5. So we look to see, is it in turning point form? No, it's not. That's standard form. So we're going to use the quadratic formula. If you haven't seen the quadratic formula, we're going to see it in a sec. It looks very complicated. It's messy to use, but it's not difficult. So the first step is to find a, b, and c. A will be 1, b will be 5, c will be 7. Write out the quadratic formula. X equals -b plus or minus the square root of b squared take 4ac all over 2a. At your level, if you were going, you wouldn't have to remember that. We would give it to you on the page. But you do need to write it down, because our next step is to substitute all the values into it. And if it's not sitting in front of you, you will get it wrong. So we need to put b where b is. B is 5. There's 5. Negative, plus or minus. Square root symbol. Put the 5 where the b goes. Minus 4, always 4. Times by, I would put the bracket there. Whatever the a value is, 1. Whatever the c value is, 7. All over 2 times whatever a is. Now simplify. -5 plus or minus the square root of 5 squared is 25. Take 7 fourths is 28. 25 take 28 is negative. So that instantly tells us there's no solution. This graph will not cross the x-axis. And if we keep going down, we can keep writing it. -5 plus or minus the square root of 25 take 28 over 2, which simplifies down to this. That would be the line of symmetry. And the turning point will still lie on that point. But because it doesn't touch the axes, this is at this stage of your maths meaningless, except to tell you that it doesn't cross the x-axis. If you do imaginary numbers later, that will change. And we should always say what we found. In this case, there is no solution for x where this equation can be 0. Here's one where it does work. So x squared plus 6x take 5, a is 1, b is 6, c is -5. Substitute those values into this equation, you get this. Simplify this, you get this. You end up with -6 plus or minus root 48 on 2. Now, we're going to simplify this root 48. 12 fours are 48. Root 4 is a square number, so that will simplify to 2. Break this fraction up. We end up with -6 on 2 plus or minus 2, because I've simplified that. Root 12 divided by 2, the 2's will cancel. 6 divided by 2 is 3, -3. That's how I get this. That's how I get that. So your two solutions are going to be -3 plus root 12 and -3 take root 12, with the line of symmetry at x equals -3. We can find the rest of the turning point by substituting in -3 into the equation, which gives us -14. We can now state the turning point. We can also find the y-intercept by substituting in 0. I don't think I did it here. I must have done it somewhere because I can see the answer is -5. Oh, it's right here. The standard form tells us the y-intercept. So there it is there. And now we can see our function. -3 is our line of symmetry, and we're going to add root 12 and subtract root 12 from it. There's subtracting root 12, there's adding root 12, and there's the 2 points there that it intersects. And that's how you can use solving of equations, because that's all we've done here is solved equations, to find the x-intercepts. I hope that was helpful. Thank you, everyone.